Welcome to question 8 of the 2013 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 8 we're told that a continuous random variable x has a probability density function given by the hybrid function f of x. We're also given extra information about the derivative of x sine of pi x over 4, with the aim of finding the expected value of x, which is what this question really is asking us to do. So this expected value of x on the formula sheet is the same as the mean or mu value, which has a formula for a continuous random variable of being the integral from negative infinity to infinity of x times f of x dx. So therefore, the expected value of x for this question can be found by evaluating the integral between 0 and 2, and that's where the probability density function's above the x-axis and it's 0 everywhere else, of x times f of x, so it's going to be x times pi on 4 times cos of pi x over 4, and that's going to be with respect to x. And now the reason why we've been given all of this information here is that we don't have a rule on our formula sheet that allows us to integrate x times cos of x directly. So we're going to need to make use of this information and undertake a process known as integration by recognition to answer this question. So if this is an equivalent statement, we can integrate both sides, so we'd end up with the integral of the derivative d dx, x times sine of pi x over 4 dx, and on the right hand side this is going to equal the integral of pi x over 4 times cos of pi x over 4 with respect to x, plus the integral of sine of pi x over 4 with respect to x. So in that line we've integrated both sides of this given equation, and we've also split up the integral on the right hand side over the addition sign here, which we're allowed to do. That's one of the properties of integrals we are allowed to apply. So now on the left hand side we have the integral of a derivative, and they are inverse operations, so we just are left with x sine of pi x over 4, and that's going to equal the integral, which I'm putting in purple because that's what we want to be able to calculate the expected value, so pi x over 4 times cos of pi x over 4. And now the integral of sine of pi x over 4 is going to go to negative cos, and it's going to be negative 4 over pi cos of pi x over 4. And now if we were finding the general antiderivative, we'd need a plus c value here, but because we're about to use it in a definite integral, we won't need the plus c value. So just to wrap up our working on this page, we now know that the integral of pi x over 4 times cos of pi x over 4 with respect to x is equal to x times sine of pi x over 4, and then we're going to add across this term that's still on the right hand side, so it's going to be plus 4 on pi times cos of pi x over 4. So that is the antiderivative, which we'll now use to calculate the expected value of x. Now on this slide I've just kept our final result that we just found. So we can say that the expected value of x is equal to the integral between 0 and 2 of pi x over 4 times cos of pi x over 4 dx. So that is what we discussed back here at the start of the question. And to evaluate that, we're going to use the antiderivative evaluated between 0 and 2. So therefore, our expected value of x is going to equal, and we're going to substitute the upper terminal of 2 into the antiderivative first. So we'll get 2 times sine of 2 pi over 4, which is the same as just pi over 2 when we simplify, plus 4 over pi times cos, and it will also simplify to pi over 2 when we sub x is 2 into that, and then we're going to subtract away when 0 is substituted into the antiderivative. So we'll have 0 times sine of 0 plus 4 over pi times cos, and the part inside cos is going to become 0 when we substitute 0 in. Now we need to remember our exact values, so sine of pi on 2 is simply equal to 1, cos of pi on 2 is equal to 0, sine of 0 is 0, and cos of 0 is 1. So therefore, the expected value of x for this question is equal to 2 times 1 is 2, and then we add plus 4 over pi times 0 is just plus 0, and then we subtract away from that. 0 times 0 is simply 0, and then we're going to have 4 over pi times 1, which is just 4 over pi. So therefore, our expected value of x, which is what this question was asking us to find, is simply equal to 2 subtract 4 over pi. So that is the answer to this question. So from the examiner's report, we can see that 21% of students got full marks for this question, with 47% of students getting 0 marks for this question. And the examiner's report goes on to say that this question challenged many students, and that identifying the formula for the expected value of x was key to recognising the need for the provided derivative. That was the derivative of x sine of pi x on 4, and that led to the antiderivative that was necessary to complete this question. Care then needed to be taken with the substitution and evaluation of the expected value of x.